Okay, friends, so here we go. This is the first day of completing the square. So this is a really important skill, and we're going to use this today in the next lesson and in the word problem lesson. So when basically completing the square is going to take standard form and put it in vertex form. So vertex form, again, is this. We need this information to help us with the optimal values so that we can do word problems and maximize profit, maximize area, that kind of thing. So this is going to be a very effective way to do that. There's just a few steps to follow, but those of you who like steps, you can, there's a procedure to it and you do the same thing every single time. There are a few questions in the textbook for homework. I've also put a worksheet in this module because the more practice you do with this, the better off you'll be. This year, we're just going to focus on whole numbers. Next year, if you take 11U, you'll have to complete the square. Sometimes you might have to use fractions. It gets much more difficult, much quicker. So make sure you do as much of this work as you possibly can, whether you do it now or as a review at the end of the summer or whatever. You have to make sure that you've got this skill down pat. Okay, so we have already used the zeros or the x-intercepts to find vertex form, and both of these are going to be important. So if the question says graph using the x-intercepts, then you would do this way. If it says graph using complete the square, then you have to do it the complete the square way. And eventually, when we get to the word problems, the questions are going to be much more difficult. So trying to factor and use x-intercepts is really going to be not possible. Okay, so if it says to find the vertex of the parabola and it says using x-intercepts, then these were your steps: factor, solve for the zeros, take the mean, find the axis of symmetry. So there's only two of them. You add them together and divide by 2. Find the optimal value. So sub the x in to get y, and that becomes the vertex. Okay? Well, we need another way, right? So we are going to complete the square. So let's just factor these equations for a second. So we are looking for two numbers that multiply to 9 and add to 6. So we have 1 and 9. That's not going to work, but 3 and 3 will. Okay, and another way we can write that is x plus 3 squared. In this one here, we're multiplying to 36 and adding to negative 12. So I'm going to cheat a bit. 136 isn't going to work. 218, not going to work. 3 and 12, not going to work. So what are we at? 3 and 12, 4 and 9, no. 6 and 6. Oh, if we do negative 6, you get negative 12. And again, you could write that like this. This one here, maybe you're seeing a pattern, right? So when you multiply to 25 and add to negative 10, there's not many multiples of 25, but 5 times 5 is 25. And then to get negative 10, then you would need negative numbers. So we call these trinomials, we call them perfect squares. Okay, which means that if you look, you can square root this number, and that gives you what goes in there, right? So we are going to use completing the square in order to force a trinomial that has a perfect square. Okay, so trinomial means 3 terms, so that's going to be important. So we're going to count the number of terms that become first, and we're going to use that when we do our factoring. So what today we're going to do only when a equals 1. The next lesson will be when a is not 1. Okay, and it's a little bit more complicated, but not too bad. And then the c value is half the b value squared. So what we're going to do, that is essentially how one of the first steps of completing the square. You want to do half of b and square it. So you do need to remember what standard form is. So we're talking about, like, this is ax squared, and then the b value is in front of the x. So we are going to make perfect square trinomials, which have 3 terms, and we are going to change them into perfect squares, trinomials. So if we had x squared minus 12, then half of b squared would be 12 divided by 2 squared. 12 divided by 2 is 6. Squared is 36. So in order to make this a perfect square, we would need to add 36. And then if you factored, the factors you would want to use would be 6 and 6. So then we would normally write it like this, but that is equivalent. Okay, and notice this is the beginnings of factored form. Or sorry, vertex form, which is what we're trying to get to. Okay, so you're going to fill in this binomial here and make it a trinomial. We want a third term. So you have the b value. Again, that's in front of the x. If it's negative, just keep the negative. So negative 8 divided by 2, which is negative 4 squared, is 16. So then you write 16 in here, and then when you factor, then you actually put the negative 4 down there, okay? So you can't just add a number. So x squared minus 8x is not the same as x squared minus 8x plus 16, right? So if we are going to add the number, if we want to effectively make it end up as 0, we have to subtract the number as well. So when we complete the square, we're going to do half of b squared. That's important. And then we're going to do whatever that number is, you're going to add it and subtract it. So that's what this is saying. Add and subtract. Actually, I'm just going to put that in there too. Okay. So now let's try this question. Okay, so right now we are only concerned with the b value. So 21 is not half of b squared. So we're just, that 21, we're going to leave it there, okay? But we are going to focus more on looking at this and making a new trinomial. Okay, so we're going to make a perfect square trinomial because right now this is not a perfect square. But we're gonna make one using completing the square. So you have the b, so 4 divided by 2 squared. Now you can write that like this if you're used to that, that's fine. You don't have to write it like I've been doing. And then 4 divided by 2 is 2, squared is 4, okay? So now we are looking at, again, this thing here. We did half of this b value. So right after the b value, you're going to do the complete the square part. So the plus 4 minus 4, and then we can't change the equation, so we need that 21. Okay, so I'm going to use the same color I used up here, the add and subtract. That's this here, add and subtract. If you have positive 4 and negative 4, then that makes 0. So technically, that does not change the equation. I haven't changed the equation at all. I've just written it as a different form. Okay, so now we have a number that has 1, 2, 3, 4, 5 terms. So when you factor, when you go to do the factoring step, we always factor trinomials, right? 3 terms. So you count 1, 2, 3. You're looking at these 3 terms, and they are the ones that you're going to factor. Now, if you hated factoring, if you hated it, the good news is with completing the square, let's go back to this one, okay? When we complete the square, if you take a look, when you do, if you look at the b here, so let's say if I do half of b, so that's 6 over 2, which is 3. If I do this one, negative 12 divided by 2 is negative 6. Negative 10 divided by 2 is negative 5. That's always, I'm going to pick a different color. This is the number that becomes the factor. So you don't really have to worry about making the t-chart and all that kind of factoring stuff if you hated factoring, okay? So you're basically looking at this number here. What was the half b, okay? So you take that half b number, and that is going to be your factor, okay? Now, you can see, actually, I'm going to write that in green, sorry. You can see, if you're good at factoring, you can factor it too. You don't even need to think about that. 2 numbers that add to 4, that multiply to 4 and add to 4 are 2 and 2. Okay, you can certainly continue to factor it, but you can also just look at this number here. That's what goes in the factor box. Okay, now. We've taken these 3 numbers and factored them. That's what we've done. Okay. Now we have some numbers left over, these ones here. So then you just collect like terms, add or subtract. Okay, so negative 4 and positive 21 make positive 16. And now we have vertex form. So now you could do the left 2 up 17 and find the step pattern, so you can do that, okay? So you're always doing the same thing when you complete the square, okay? I'm just going to skip to the end for a second because it is summarized down here. Okay, so you half b and square it. So b divided by 2 squared. You add and subtract the number you found. Then you factor, but again, that is not difficult to do. That's going to be the half b number, okay? And then you just simplify, collect like terms. Okay? So let's go do more examples. Oh, there it is. There it is again, okay? Half b squared, add the number, subtract the number, factor the completed square using that number, collect like terms, and then you're going to have vertex form, which is what we want, okay? Okay, so we're going to write each equation in vertex form by completing the square, and then we're going to, sometimes the questions will just be complete the square. Sometimes then you have to relate it to the parabola, write the coordinates of the vertex, equation of axis of symmetry, up and down, whatever, describe the translations, and you can do all the other questions that we've done before once you have vertex form, okay? So And if you want, when you're doing completing the square, and like I said, it's going to say by completing the square, then, you know, show as much work as you want. So we have to half b and square it. So 12 divided by 2 squared is 6 squared is 36. So that's the number we're going to add and subtract. And then we just put the 14 back. So if you want to do the same thing as before, highlight the add and subtract in yellow. And then this trinomial, 1, 2, 3 terms, trinomial, is what we're going to factor. Again, yes, you can certainly make a t-chart. Two numbers that multiply to 36 and add to 12 are going to be 6 and 6. But there it is right there, okay? And then you've got minus 36 plus 14. Okay, so now the vertex is, I'm just going to change colors. This is left 6, right? And down 22. So 22 is sort of not a coordinate we've used before. So these questions I probably wouldn't ask you to draw. So if you are completing the square and you still have to graph the parabola, then the parabola should fit on the grid. Okay, so that's another way you can kind of check you've done it right. Once you have the axis of symmetry, then it's just the x value of the vertex. And this one opens up. A is positive. And the maximum minimum value and when it occurs. So if it opens up, it's going to be a minimum value, which is the y value of vertex. If you forget, it says of, sorry. You want to write that down again for yourself. Of x equals 22. When does it occur? When x equals -6. Okay. Let's do another one. Half of b squared. Remember, keep that negative, -2, -10 squared. -10 divided by 2 is -5 squared is 25. Oops. So again, why do we need to write the 22 like at the very, very end? Because we want to be able to factor a trinomial. 1, 2, 3, that's a perfect square. So that's the whole point of this. So then the 22 is not a perfect square, right? You can't square root 22 and get a nice number. So then we just leave it at the end. So now we've got x. So we're going to factor x minus 5 squared. So again, that number over here is our factor. Minus 25 minus 22 is minus 47. So now vertex, this is right and down. So is 5 and -47. X equals 5. Opens up, still a positive a. And so we have a minimum value of -47 when x equals 5. And that's it. Okay, so this last one, we're going to complete the square and we're going to graph. So this one should give us a pretty nice parabola. Okay, so if we happen to get a weird parabola here, then that's not gonna be easy to graph, right? Okay, so we have we're gonna do, I'll write over here. Okay, so half of b squared is negative 6 divided by 2 squared. Negative 3 squared is 9. Plus 9 minus 9 plus 7. Oops, now it's time to factor. One, two, three, the first three terms. X minus 3 squared minus 2. Negative 9 plus 7 is negative 2. So this is nice, right? So now the vertex is, so this is right. It's opposite, right? So positive 3 and negative 2 down. Positive 3, negative 2. And the step pattern is 1, 3, 5, 7. So there's no a value, or the a value is 1. Over 1, up 1. Over 1, up 1, 2, 3. Over 1, up 1, 2, 3, 4, 5. Over 1, up 1, 2, 3. Over 1, 1, 2, 3, 4, 5. And you can check. Oops, sorry. So again, this is a nice vertex. And you can check because up here you have standard form. So this is the y-intercept again, which we got that right. Okay. And then this last question is, now this is not going to be perfect. So if it's not a perfect divisor, then just use fractions. Okay, but still complete the square, do the same thing. So b divided by 2 squared. 3 divided by 2 squared is 1.5. Squared is 2.25. Just use fractions. And this one for sure, you would not have to graph. And just put the numbers in your calculator. Okay? So read the question carefully. Again, make sure you do the worksheet as well as the textbook questions, because we're going to make the complete the square for the 6.4 day 3 a little bit more complicated. Okay? If any questions, please email.